Since we are still doing the fundamentals part on the basic of math, so I need to give you some lesson first, and hopefully if we have done at the end of the lecture, I can start the group discussion. But if not, then maybe next time. Oh, by the way, since there will be a lot of things. First one is holiday, right? In Monday, so I think we need to have a class on Saturday. Because this Saturday is supposed to be adjusted class, and I will be gone for in the first week of October and the first week of December. I will not be here, so at least there will be one classes for basic of math on Saturday.
Like this same time, like
No, I think it should be earlier, so you can have time to go. Right? You can go somewhere. So I need to check the schedule. So I hope, for example, if you get like 10 to 12, I just need 2 hours. So 10 to 12, and then you finish, and then I think it should be. Okay.
I got a question.
Yes.
For those like we taking material science, so kind of like rotate for the same period. So should we skip material science for this or material science?
I mean, what time?
Because we all have to take another Monday things on Saturday.
What time?
Oh, like 10 to 12.
Oh, really? Okay, I can adjust that for you.
Group 5.
This Saturday, right? This Saturday.
Yeah.
So I would like to know your schedule on Saturday. How many classes you have? What time? 8 to 10. 8 to 10. 10 to 12. 10. Our class. Okay, okay, so let me get you through. So this is our groups. This is for our discussion, group discussion. And then we might have a class on Saturday. What is Saturday? September 23. And then since some of you have already have a schedule on Saturday from 8 to 10 and then to 12. So what I'm suggesting is the afternoon class. Only 2 hours. I just would like to have a 2-hour class. So 2 hour, no need 3 hour. So 2-hour class. Probably from this. Okay. The classroom, I will decide after I get which classroom. Okay. I need to check. Now to start our class, before we start, group 1, where's group 1? I would like to have a group introduction. Come all of you, just quick, just 5 minutes, all of you, come up in front. Okay. So please do self-introduction, just name, origin, well, anything that make it fast. Okay.
Hello everyone, my name is Alpha, I'm from Indonesia.
Okay.
Hey everyone, my name is Ben and I'm also from Indonesia.
Okay.
My name is Pam and I'm from Thailand.
Okay.
Hi, my name is Brittany and I'm from St. Lucia.
Hi, my name is Dane. I'm from the Marshall Islands.
I'm Jackie and I'm from Macau.
Hello everyone, my name is Lin Zhihai. Lin Zhihai, Taiwanese.
Okay, thank you. Okay, thank you. Group two. Okay. Every period we need to group and then move to.
Hello everyone, I'm Vietnamese and my name is Nguyễn Nhật Đan, but you can call me Dan.
Hello everyone, my name is Rico Fernandez. You can call me Rico. I'm from Indonesia.
Good night everyone, I'm Franco, I'm from Paraguay.
Hello, I'm Dylan from Belize.
Hi, I'm Cindy. I'm from Indonesia.
Okay, thank you. Give me one more group and then you can have lecture. Okay. Group three. Group three. Okay.
My name is Vicky. I'm from Indonesia.
Celsius Leo, I'm from Fusion. Celsius.
Hello, I'm Kai from Myanmar.
My name is Victor from Taiwan.
Hello guys, I'm Peter from Thailand.
Okay. Okay, thank you. Okay. Okay, the next group will be after the first break, okay? Okay, let's continue our discussion. I think we finished some factoring for some expression in quadratic equations for this one. And I want to just make some quick review. So we have what we call the rational expressions. So something like, for example, 2x over x plus 1, or x cubed minus x over x squared minus 5x plus 6, or x over square root x squared plus 1. We call these rational expressions. So rational means that we have we call the numerator and the denominator, okay, if you remember the term. So what is so interesting on these rational expressions? This rational expression, what you need to be aware of is the denominator, this one here, okay? Especially after you learn on functions, right? But we start from just a rational expression, not a functions. So you need to be aware of this denominator. So rational expression, or we can call also the fractional expression. So to start with, this rational expression is, we are going to start with the domain. Okay? So the very basic rational expression is 1 over x, right? Okay. And then by definitions, to make this expression defined, then we need to have the x is, or maybe let me write completely. So we need to have the domain that x is not equal to 0, okay? And then another simple rational expressions, for example, if we have 1 over square root of x, what will be the domain? What will be the domain? Greater than 0, okay? This is because, let me write notes here. If we think on the square root of x, the domain is, right? So then we have this expression need to be a positive expression. Now, let's say we have, so example, find domain of expression. So this is A, this is B. Okay. Okay, what's the domain for the first one? Again, with the focus only for the denominator, we need to get this not equal 0, right? So basically how we process this in our perspective is we can just make it, maybe let me write on the right side. We just make the factors like you usually do for factoring any quadratic equations. For instance, if we take this, let's say equaling to 0. Let's say equaling to 0, okay? And then let's take the factors, okay? So I think you guys get it. Like, I think it's easy example here, okay? So the one that makes 0 are 2 and 3, which means that this 2 and 3 is the one that makes 0 here, which means the domain should not be equal to 2 or 3. Okay? So domain with 2, 3. Okay? Yeah?
Why can't it have been 1 and negative 6? Sorry. The idea of finding the middle term is that we need to find something to multiply to get 6 and minus and add to get negative 5.
Yes.
So why can't we have used
5 and 1.
yeah.
Use 5 and 1.
6 and 1. So
Negative 6.
Negative 6 and 1. Can it be done? No.
no.
Right? Okay. Yeah. Okay. All right. Any other questions? It's okay, right? Supposed to be okay, right? Okay, the next one is number B. Okay. So obviously we see that this term here is, we have x minus 5 on the denominator, which means that the ones that make 0 is x equal 5, right? And then we have the square of x, right? Which means that it needs to be positive or 0. So we can say that this can be domain can be x greater than equal 0, and for this part here, domain is x not equal 5. So we need to write completely that the domain should be include Okay? Or you could say it can be any real numbers equal or greater than 0 except 5. You can also say that. Okay, I think domain should be okay, right? We are going to see another domain in a function. So this is just on general expression, particularly on the irrational. Okay. So I hope. How about this one? Do you familiar with this? Let me just give you some simple expression. Simplify this. Easy, right? Just checking. I would like to know, like, how many of you are still need to take time to simplify this one? Okay. So how many are still maybe taking times doing this? 3 over x minus 1 plus x over x plus 2. Which means that you need to simplify it and make it into one rational expression. Okay, that's the intended question. Okay, and then this is, I think, later when you learn calculus, there will be some parts in the, in the integration part that you need to separate some fractions into small fractions. I think we are going to see also later. I think in our class in the basic math also, in chapter maybe 8 or 10, I think, when we learn about the system of linear equations. So the first thing is we are going just to multiply the denominator, right? So we multiply. Okay. And then we divide with each one of them, and we multiply with each numerator, right? Okay. So I will have 3 x plus 2, and then plus x minus 1. And do some multiplications, right? So 3x plus 6, x squared minus 6, right? So x squared, let me write x squared plus 2x plus 6 over. You can also multiply the denominator. So x squared plus x minus 2. So now from this to fraction, you could get this. And suppose that you have this, and then you would like to make this small fraction. Can you do that? Let me just introduce you the method. Okay. Can you separate this, make it into this one? Anyone know how? Okay. So the idea, okay, we still focus on denominator. Okay. And then we see that, okay, we can factor it. And we know the factor is this one, right? So first we write let's say we write that since we can factor out this become this, then we can force out a small fractions that has this component. Okay? And then let's say the top of the equations is just, let's say A or B. Okay? But the idea, this A or B, when we try to solve this, we need to make sure that AB will be producing this, right? Okay? So what can we do? So we are going to take times, we multiply this, divide with each one of them, and multiply with A, and do the same thing with this, multiply with B. Okay? What does it mean? It means that we are going to multiply all of them like our usual expression here. We're going to exactly doing this, but with a constant, with a constant A and B, or coefficient A and B. So let me write. So we are going to have A x plus 2 plus B x minus 1. Okay? And then let's try just simplify. So this one becomes ax plus 2a, and this one is bx minus b. Okay, and then the same component downside here. Let me just write as it is. All right. Now let's group all together. We have variable x, ax and bx. Let's group them together. Okay. And we have a constant 2a minus b. We group them together. All right. Okay, so we take this a plus b x plus 2a minus b. And I suppose that this is need to be equal to, what is the question? X squared plus 2x plus x plus 6, sorry. And then this will be x squared plus x minus 2. Okay? And now, all the calculation for A and B, they need to have the same value if we want to make it, or if you want to multiply. We need to make sure that this is equal to this one. The right should be equal to the left. Which means we have x, which has this coefficient, a plus b. So a plus b needs to be equal to 2. Okay? So 2a plus b equal to 2. And then 2a minus b is 6. And how about x squared? 0. Nothing, right? And then 2a minus b is equal to 6. Okay, let's solve this. I think we can just, takes time to solve. So that's plus. So we have 4a equal 8. So a is 2. And if we take minus, here, let me write again. So minus, it's 2b minus 4, so b is minus 2. Okay, I think it's pretty good. So we are going to have a is 2. Let me check. Is there any mistake that I make? Wait. Oh yeah, a plus b. Why I'm writing to a plus b? Good. Okay, good. So a plus b is 2. And then 2a minus b is 6. Now it's correct. Okay. So that's plus 3a equal a plus b is 2. So let me check. Should be x minus 1. It's 8. So a is if I take another one, let me check. So if you take 2a plus 2b equal 4. If you take minus, it's 3b equal 10. Yeah. Wait. Oh no, I know what's happening here. Shouldn't start with this. I need to mention this first. Okay, I think there will be. I forgot. I'm sorry. Since we have the same degree, so we cannot directly separate this. To separate this, we need at least less than 1 degree that we can make it. But anyway, good to remember. So the first way is we're taking this one, and then we have our new expression, and then this expression, now we can separate. Okay? I forgot to mention that. So this one, okay. So from here, now we can go to the what we call the partial fraction. So we can have, so this, let me write here. So x plus 8 and now we can have this. And then we can have, this should be the same, so a plus b if this is and have another problem, then we might skip for a while. But this is supposed to be in the next chapter, but let me just introduce you. So a plus b is 1 and 2a minus b 8. Now we can get 3a equal 9, so a is 3. And then minus 3b is negative 2. Okay, I think should be okay. So we have 1 plus 3x minus 2 minus 2 or x minus 1. So if we plug in this 3 over x minus 1, if we want to check so x plus 8, right? Okay, and then this one is equal. Okay, done. So this will be the separations. Okay, sorry. So, yeah. So if we want to separate, become this small fraction, the requirement is the degree on the top should be at least 1 less than the bottom one. So if this is the quadratic, this is linear. So this one, so this one is degree 1. This one is degree 2. Okay. Okay, now you can separate them. And what is x plus 8? X plus 8 is coming from, or let me just maybe to make it clear. And then make it all this. Oh. Okay. So first is, if you have this expression, you have the same degree, we need to simplify the form. I think you can define, and then you see that we can make it 1 plus something. Okay, and then we have this expression that we can separate. We can separate become this, and we need to check a and b, check a and b, and then finding ab, and then you can try one more time to check whether it's correct or not. Okay, some of these expressions we are going to confirm in details later on when we learn about, first is the polynomial expression, and then second one is on the system of linear equation, which includes learning about metrics and how to solve linear equations, which involves this one, involves how to get, we call this a partial fraction. Okay. Just a quick glance on what we are having later on. Okay. Okay, so it's a little bit jumping to another section, but I think still okay. some multiplication property. I believe this should be. I believe you are familiar with this, right? So I don't think I will inform you any of this multiplication. Okay, I think one more example, just to see how much we can handle the rational expressions. Okay, so aside from expanding the expressions, multiplying the expression, or adding the expression, we could also take time to simplify. I think it's similar to last week. 1/2 or negative 1/2. Anyone can solve it? Simplify it. Okay.
I guess I can.
Okay. Okay, group 7? Where's group 7? Anyone want to try?
I know the first thing that we should attempt is to factor the numerator.
Yeah.
That's all I know.
Well, that's a good step. How about group 6? So I think the problem here is what you need to be aware of, like last week, what I also make some mistake is how we know this 1/2 as in the power. Sometimes our brain feels that because we are getting used to the power of 1, 2, 3, 4, we are not really getting used to the fractions. We sometimes make some mistake on that one. So suppose that we have, for example, if we have the 1/2, and this is negative 1/2. So suppose that one of them we are going to factor. You could try that one. Because you see that if you look at the form, if we take this is the first form and this is the second form, the second one has a multiplication of x squared, right? It means that probably the one that needs to be factored out is this one, right? So there will be something and then plus x squared something, right? So the factor multiply with 1 plus x squared, right? Perhaps that is one way. Or maybe not. Oh. Almost. Okay. I think Okay, I think you can simplify again.
down to the duration.
I mean, you can make it this.
Yeah, but I mean, usually try to make the
Not always, not always. Not always. You can do also. You can simplify this.
you can just
Yeah.
yeah, there will be
1 plus half, right? 3 over 2. Right?
real
I think it's. I think I have to prepare it. Okay, I would like to see from the other students. Okay, one student got correct. Any other one? Would like you want to try? Okay, from this side, anyone would like to try? Okay, another student's correct. So 2 students correct. So let me write here. Okay, let me write. So to solve this, we can take the factor. So let me take the factor 1 plus x squared negative 1 over 2, right? So we are going to have 1 and then minus, or this one going to be, so if we take negative 1 over 2, 1 plus x squared negative 1 over 2, what will be this one? So let me write here. So this, okay, if I multiply this with 1 plus x squared, or maybe let me write with negative 1 over 2, if I multiply this 2, so this is negative 1 over 2, this is 1, right? This will be 1 minus half, right? Okay? That means when we factor out with the negative 1 over 2, the left part will be this, right? Okay? So 1 plus x squared. Okay, and then this one is negative x squared. And then we see that, okay, we can cancel this, right? So this was 1 plus x squared, and then we can simplify it again. So 1 plus x squared, negative 1 over 2. This one is 1 plus x squared. We can put down the numerator. So we are going to plus 1 over 2. So 1 over. I think we can just stop until here. Okay. Okay. I think you need to get used to this. let me copy it for just a moment. I forgot to mention this. Okay, any questions regarding this one? That should be okay, right? Okay. Okay, now I forgot to mention this property. Some mistake that might happen. First one is a squared plus, or maybe a plus b, sorry. So a plus b and then squared. And the mistake are a squared and then plus b squared without the 2ab. Okay, so this is, you cannot do this, right? And then the second one is square root a plus b. And then you write square root a plus square root b. And again, this is wrong. And then another mistake that might happen is, and I see a lot, is a squared plus b squared under the roots. And then you write that this is going to be a plus b, which is also wrong. Okay. And then 1 over a plus 1 over b, you get 1 over a plus b, like that. This is also wrong. And then you have this cancellations, which is also wrong. And the last one that is a common mistake is this one. This is also wrong, okay? Just need to be aware of these common mistakes, okay? Okay, just a quick review. But if you have like already have a good fundamentals, I don't think you need to write all of this. Okay, we move to some of the equations. Okay, so the first one is the standard one, the linear equations. Something like if you have the ax plus b equals 0, that's linear equation. X is the variable, a and b are the constants, the real numbers. And then remember that we have the zero, we call the zero product property. So if we take a, b like that, equaling to 0, which means this is a equals 0 or b equals 0, which you apply to the factors, right? Sometimes you apply to the factors, finding the zeros, right? Okay. And then, for example, the second one is the quadratic equations. I think linear equations should be okay for you. I don't think we need to have like a more example. So quadratic equations is we get the ax squared plus bx plus c equals 0. A, b, c are all in constant with the real numbers, and a is not equal to 0. I think this is very basic, right? So, and I have told you how to factors, right? How to factors if we have like, for example, let me just get in quick here. Okay, if we want to solve this, then we need to make sure that one side is 0, right? Like these equations right here. which we can factor easily, right? We can factor easily. So the one that makes 0 are x minus 3 equals 0 and x plus 8 equals 0. So x is 3 and x is negative 8. And you could try each one of them and you will see that it's getting the same conclusion, that both are solutions, right? So solutions, so we can write the solutions are x equal 3 and x equal negative 8. Okay. But remember, when you have, for example, the x squared, let's say equal 5. So if we want to solve this, then don't forget that we have plus minus. Okay, so we have positive value and the negative value, because both, if we are squaring both sides, they are getting the positive, right? Okay, just a quick note. Okay, now just a quick review on the quadratic equation. So let me write again: x squared plus bx plus c equals 0. Okay, now what I would like to do is, let's say we are going to multiply this with 1 over a. So by doing so, we are getting x squared plus b over a, x plus c over a, and then equals 0. Okay, now if we are trying to do the perfect square, anyone familiar, or who are not familiar with the perfect square, the terms? Familiar or not? Let me give you example, maybe the example with numbers. Okay, let me try with green. So x squared minus 8x plus 13. Can you factor this? Can you factor this? No, right? I don't think we can factor because 13 is a difficult number, right? I mean 1 and 13. There's no other factors that make up the 13. So what do we do? Huh? Yeah, that's one way. But before we know the quadratic formula, how can we solve this? 12, 1. But 12 multiplied 1 is 12, not 13. Right? So the idea, how about we are going to plus something that can make this x squared and negative 8x can be factored completely. Okay? Now the idea is what we call the perfect square. So if, let me write here, if we plus 16, and we still write, and then the right side also plus 16, like that. Okay. Can you factor this out? We can factor this, right? So we can write let me write with green. So x minus 4, right? And then let's move 13 to the right. We are getting 3. Okay? And then x minus 4, we get plus minus square root of 3. So x is plus minus square root of 3 plus 4. Now, what we have done here, we are forcing this equation to have a square. So we are going to plus with something that when we are trying to factor out, it will be factored out with a perfect square, which means it's like a square, okay? It's the same size. The same size, x minus 4, right? Okay. And how we are exactly getting this 16? We're getting 16. This 8 divided by 2 and a square. So 8 divided by 2 is 4, 4 squared. And it will be working to all types of the quadratic equations. Okay. Now that's what we call the perfect square. Okay. So this is the perfect square. Sometimes this method is, I believe, if the equation is not complicated enough, this will be the best way, I think, before you try the quadratic formula. And the perfect square is actually used to prove the quadratic formula itself. Okay? So from the perfect squared, let's try and take this one. So we are going to add a constant that is, we need to divide this by 2 and then square. So we are going to have b over 2a and then square. So let me write here. So x squared plus b over ax, and then we need to plus b over 2a and then squared. And then move negative c over a to the right, and then this is also plus b over 2a squared. Okay? And then this part here is become x plus b over 2a squared. Okay? And this one, let's say we are going to complete this and write 4a squared like that. And then this will be minus 4ac plus b squared like that. Okay? And what else we can do? That takes the square root for both sides. Okay. Okay. This one on the left is x plus b over 2a. We remove the square because of the square root. And on the right side, we still have the square root. And then we write b squared minus 4ac. And 4a squared becomes 2a. And then, and then this x is, this is plus minus, sorry, because of the square root. So x is minus b plus minus b squared minus 4ac over 2a. And then you get the quadratic formula. So I hope you can get this formula by yourself. Do not memorize it. I believe that you learn formula, you memorize it. But it's actually just taking sometimes to do the perfect square, and then just simplify the perfect square of this ax squared plus bx plus. Okay.
gonna make us the write this in the test.
Huh?
You're not gonna make us to write this in the test.
I don't know. But don't you know how to get the formula, right? And from this formula, the quadratic formula, one of the, I think the unique property that it has is this square root here, which we call the discriminant. The discriminant. I will write in the new slides. And what's the implications to, at least to the solutions? Okay. I think we've done this, right? So we also done this, okay, the perfect square, completing the square, and then we have the quadratic formula, and then the discriminant. Okay. So discriminant is if this expression either equals 0, positive or negative. And I think because we know the formula, it has the square root, which means that if positive, it means that it will be having two solutions because of positive, negative, right? And if it is equal to 0, then it means it's only one solution. And if it is negative, which means it's probably an imaginary thing, or we can say it's no real solution. So we say it's no, it doesn't have any real solution. Okay. And sometimes we need to solve using the quadratic equation, but the equation itself probably like having a rational expression like we did before. Let me try again. Okay, let me try again and see if you can solve this. Okay. So solve. This is 3 over x. So sometimes the question just asking solve, and then you have the algebraic expression, which means you need to find what kind of x that is going to be a possible solution. Anyone? Any other? Yeah, do you think three is solution? So what we can do here is we can multiply this this one system with the factor of this, right? So the idea is we want to remove the denominator. So what I want to remove, let me write here, 3 over x minus 2 over x minus 3. And then I would like to multiply with x and x squared minus 9. Okay, and then this one also, because we want to remove all. So we need to multiply with the same factor. So this is also the same. So we could take this, right? And then each one of the x and x minus 3. So we are going to have this one getting the x plus 3. And this will be getting the x squared minus 9. Okay. Now, the next term, we are going to solve this expression. So this is multiply, okay. And then this is negative 12x. Okay, and then we can multiply okay. Oh. And then we get x squared. Yes. Almost. Not finished. Okay, and then you can factor this expression, right? You could get x plus 9 and x minus 3, which you can infer to this is negative 9 and x equal 3. Okay, most of the students, if they can solve the expression, they will get this number, negative 9 and 3. But is it the correct solution? Yes? From here? Yeah, this one, right? Yeah.
Should be 8.
Negative 12. Go here. 12 minus 6. 6, right? Okay. Okay. Now back to this x equal negative 9 and x equals 3. So what should you do next? So for this kind of expression that involve the rational, we need to check one by one. So check negative 9, go through the system and check x equal 3. If we check x equal 3, notice that we have this 2 over x minus 3, right? So we have 2 over x minus 3, which if we take this, then it will be undefined. Okay. So this is not a solution. So the only solutions that will be possible for this equation is the x equal negative 9. So we need to check solution. Okay, so check solution. So sometimes for quadratic equation or any expressions that is not by default like a quadratic one, you need to check solution. And you could remember what kind of equation that you need to be aware of. Okay? So let me try another example. Okay? Another one is this one. Multiply with x and x squared minus 9.
Oh, x and x.
Yeah.
Oh, the right one as well.
Yeah.
Oh.
Okay, again, let me rephrase what we have done here and how and why we need to multiply with 3. The reasoning is x minus 3 and x squared minus 9 is the one that we need to remove, right? Okay, that's the idea. How to remove? Then we multiply with them, right? So the first thing is x squared minus 9. If we think through the x squared minus 9, it has a factor x plus 3 and x minus 3. So if I multiply with the x minus 3, I can cancel the x minus 3 and it will be left on the x plus 3, right? So if we multiply with x squared minus 9, we can cancel this one and we can cancel also this x minus 3. And then the left part is the x plus 3. But how about the x? We need also to remove this, right? So that's why we need to multiply x and x squared minus 9. Okay? I hope you get the idea. So removing the denominator by multiplying with some terms. Okay, next one is this. Oh, really? So it means that it's not a solution. The only one. Okay, for this one, any idea? Anyone else already done that? Okay, almost close. How about this side? Okay, now, okay. Okay, idea is to remove the square root, right? The roots. Okay, we need to remove the roots. So how do we remove the roots? We need to take the square, right? But of course, if we are going to take this square like this, it will be problematic, right? Because we have this two components. So the best way maybe we move 1 to the left. Okay. So 2x minus 1, and then the other side will be that roots, right? So take the squared, and I think now it's better. We can expand this. Okay, and then we can simplify it. Minus 2, right? Minus 2 plus 1 is minus 1, right? Okay. And now we take sometimes to factor, and my suggestions, as I mentioned, if you want to factor, you can make a table like this, right? And then the only way to make 4x is 2x, 2x, or 4x, x, right? But I think it will be 4x and x, right? 4x and x. And then on the right side, we are going to plug in any number that when we multiply, it will be -1. So it could be 1, -1, or -1, 1. And then we check, cross multiply. And if this is, when we add both of these cross multiply, if they are equal to -3, then it's correct. I think it's correct, right? -4x plus x is -3x. So I think we can factor and get that this is going to be 4x plus 1 and x minus 1, which means the one that will make our solutions is probably, we're still not sure yet, is x equal -1/4 or x equal 1. But again, the same as what we did before, when you see this denominator, you should be aware of, maybe there will be something related to domain. Okay. Like this one here, when x equals 3, it will be undefined, right? The same thing will happen with this. We have the square root, okay? So it's better to check, okay? It's better to check. So check solutions, okay? So check solution. So we could check to, so let me write the solution is the equation is 2x and then 2 minus x. So check -1/4. So check -1/4. So this will be -1/2, 1 minus 2, and then plus 1/4. So it will be 9/4 or 3/2. So this will be 1 minus 3/2, which is the same, right? So it's correct. And then check x equal 1. So we see that the right side becomes 0, the left side is 2. So 1, or maybe let me write. So 1 is not a solution. Okay. So the only solution is x equal -1/4. Okay. So this is not a solution. Our class at, I think, 3:45. Okay, 3:45 or 8. Sorry, not 3. 8:40. 8:40. Why? 8:40. 8:40. So around 24 minutes. Okay, around 24 minutes. Okay, now I think we move on from the factoring and then the finding solutions for rational expression or algebraic expression. So we move to inequalities. Okay, inequalities. So let me write inequalities.
In like the real test, do they have to write the check solution out, or is it just like the, so we know it's
You can write a check solution and then x equals something is not satisfied. It means the only solution is equal. I think you can write it. No need to write all the process as long as you are maybe mentioning the important part. Yes. Yes. So this will be the last part for today, the inequalities. So suppose we have, let me go through just an example, okay, so we can go faster. So let's say we have 4x plus 7 and then less equal 19. So let's start with something very simple. Okay, now if the question is asking, for example, let me write two forms here. So first is equaling 19, okay? But the second question is having less equal. So what does it mean? It means the first one is trying to ask what is x 1 point, right? On the exact point. So we could say that this one has a solution, and we could solve this. So it becomes 12. So x is equal 3, right? And then if we would like to make intergraph, what will be our solution? So 1, 2, 3. So this will be our solution. Oh wow! And then if we look on this inequality, how we can solve this? Actually, for this linear one, is quite simple. It's just like when you do the linear equations. So exactly, we can just try to take this and we just move this to the right side, and then we get that okay, x is less equal 3, which means that we could write solution is x less equal 3. And if you want to write and make it into the table or the line, then all the point 3 and all the way to the left is your possible solutions. Okay? So in inequalities, instead of having one single solution, already several solutions, we are going to have an interval solution. Okay? So let me go again with the other example. Okay, another inequality that might comes. Let's say we have 4 less equal 3x minus 2 and less 13. Okay, let's say we solve this inequality. So we have 4 less equal this term, and then last 13. Okay. So sometimes we could only have like this one, okay, you can see, or the inequality symbol is now having two inequality symbols. Okay. So what does it mean? If you want to solve this two inequality symbols, it means that when you move this -2 either to the right or the left, you need to do it both at the same time. For example, I will move this -2 going here and going here, which means that we are going to +2 like that, and +2 on the right side. Okay. And if we divide by 3, we are going to divide all with 3. So 2 less equal x less 5. So we get that the interval of solution will be 2, include the number 2, to 5, but exclude the number. Or in the line number, or the line, if you would like to draw, and then say that maybe 0 is here, 2, this is 5. So we are getting include 2, but exclude 5. And this is the interval. Okay. Okay, we start from the linear one. Okay, very simple. Okay. But of course, we also have the quadratic equation, which we can also include the inequality, right? So we could also try the quadratic one. For example, we try, let me write quadratic inequality. So let's say we have an example of x squared less equal 5x minus 6. I think still very simple. We could take this to the left and it will be 0. And then we can find, I think we can find the factor. Right? We can find the factor. Okay. But I think this is one mistake that maybe students will make. Sometimes when you are trying to factor, you solve it directly, and then you say, okay, the solution is this and this, and then you are not checking the interval. Sometimes when you have, maybe it's so simple, but actually it's not. But for this one, I think it's quite simple. Let me go through what should we do. Okay. So first is take times to factor. So we have this, right? Okay. My suggestions for this kind of inequality, first is solve as a regular quadratic, and 2, find the root or the x, okay, and then check the interval. Okay, for example, this one, we take the x squared minus 5x plus 6, and let's just solve as usual. Let's take it just equal 0, okay? What we need is the number x, right? And then later, we need to pull that out in the interval and then check whether it is going to be less or greater. Okay? So let's just make this equal to 0. So we factor, and then we see that this is negative 2, negative 3, right? So x negative 2, x negative 3. Okay? So at least we have our proposals for our solutions. It can be maybe between 2 and 3, greater 3 or less than 2 with this interval. Okay, so we could have our interval, and then let's write this is maybe 2 and then 3. Okay, and then we check. Maybe check 0 here. Check 0, 0. It's a positive, right? It's a positive. Maybe check this one first. Check 4, 4, 4. Of course, it's positive, right? And then how about in the middle? Okay, you see, if we check, for example, what's the middle? Maybe 2.5. 2.5 here is positive, but 2.5 here is negative. So negative positive is negative. Okay. So which one is our answer? We have positive, negative, positive. Which one is our answer? Which interval? We need to have this, right? It means the middle one. Okay? So let's make this our answer. And then, because it's also take the equals, then we're going to make this include this number. So solution is, you can write x as x is between or 2 less equal x less equal 3, or we can just write this. Okay, this line number, I think it's helpful if you are maybe not really sure and you want to confirm. I think the line number will be your tools to check. Okay. Okay. Another terms solve 1 plus x over 1 minus x greater or equal 1. Anyone? None? Can you put negative point Can you plug in one to the equation? So there's something wrong. Okay, so zero is include or not? Zero, include zero. I think it's correct. Okay, yeah, it's correct. But to prove this, okay, to solve this, so I think many of you try to multiply the equation with 1 minus x, and then we remove this. But there is some problem with that. Okay, so if we multiply with 1 minus x, I mean, right here, it doesn't work because we don't know 1 minus x is positive or negative. So if we are not sure positive or negative, it means that it can be greater or it can be less. Right? Depends on what kind of value. It's positive or negative, but we are not sure. So that's why we tend to maybe not to multiply with that first. So maybe the best way is let's just move this 1 to the left. That's and then becomes minus 1. So let's write 1 plus x, 1 minus x, minus 1. Okay, let's solve from this. Okay, so we could take the denominator 1 minus x, and then we take 1 plus x, and then this will be, so divide by 1 and multiply with negative, so it will be negative 1 plus x, right? Okay, and then this is maybe make things balance. So we get 2x over 1 minus x. This way, we keep the domain similar to what we have in the original equation. That means it's helpful for us when we draw the line number. So we can figure out there will be something on the denominator that we need to be aware of. So we take the line number, and the possible answer or the possible value that what value we need to put here. The one that makes 0, of course, is 1, right? It's 2x, x can be 0, right? When x 0, we can have the solution 0, right? And the other x that is, I think, in the domain will be it's supposed not to be equal to 1, right? So let's say we are having 0 and 1, and check all the intervals. Okay? So checking 0. Checking 0 and 1. So let's say we take negative value. Let's say negative 1. So negative 1 here is negative, and then negative, negative, positive. So negative, it could be negative, right? And take the greater than 1. Let's say 2. It's positive, but this will be negative, so it's again another negative. Check the one in the middle. We have, let's say, 1/2. So this is positive, this is positive. Okay? So we take this positive over there, and this is the one we have. And remember, we are having 0 include, right? So 0 is include, but how about 1? 1 should not be include, right? So we need to have an open interval. So the solution is 0 include until 1. We want to make the one that is positive, right? Okay. Or you could works using the 0, x, 1 like that. That's also a solution. Okay, I think I will end up until here, but I would like you to scan the QR code on the front. This will be your attendance. And then, as I mentioned earlier in class, that perhaps we are going to have the additional class on Saturday. Okay, I will announce which classroom. I think if you are taking my calculus, I also plan to have additional class, but I think not this Saturday. Too much for you. You already have another course. I will look for another Saturday.